So yesterday it was pretty clear, like we had that rhythm I was talking about. You always check the end points, and then you always check the critical points, and then you work from there. So then what do you do if you don't have endpoints? Because not every problem has an endpoint. So does that mean, are you stuck? Can you not get going? Okay, what that means is that the problem has what's called an implied domain instead. Okay, implied domain means it doesn't come out and say, here is the endpoint 1, and here is the endpoint number 2, and here it is. Implied means you got to kind of figure some things out for yourself. So that's what we want to talk about today for implied domain. So one thing I want to remind you of, something we reviewed back at the beginning of the school year in August and September, were some of the rules for the things you couldn't do with domains. Okay, so can you give me some rules? You shall never do what in math? What would be violating the domains?
Violating the domain.
Okay, what are some of the rules? There's only 3 of them, and we talked about them extensively at the beginning. 0 over 0 is fine. That's called an indeterminate form. Okay? Okay, you can never have 0 in the denominator. Okay, that's one of the basic fundamental rules of math that has to do with a domain. Okay, so a denominator can never be equal to 0. That's called an implied domain. Implied means we expect everybody to know that. Okay, another thing that's an implied domain is something that has to do with even roots. Okay, do you remember what that is? What's the rule about even roots, like square roots? What can they never be?
0.
They can be 0.
Oh, they can be negative.
They can't be negative, right? So even roots have to stay greater than 0. Okay, or equal to. They can be equal to as well. Okay, sorry, I just said that. So that's an implied domain is something we expect everybody to know. At this point, you're a calculus student. You've come this far in math. We expect that you know that denominators can't be 0. That's implied domain. And we expect you know that even roots have to be greater than or equal to 0. And the last one that has to do with implied domains, there are 3, is what logs have to be. Any kind of log. It doesn't matter what kind of log. So like for roots, they have to be even. So like square roots, fourth roots, okay, cube roots are fine, but even roots. But logs, it's any log. And any log, they can't be 0 either, and they can't even be negative. So that's what's called implied domain. Okay, we expect you to know that. All right, so here's what we use. What if, okay, that's the question today. What if I don't have a closed interval? Then what do I do? Okay, so then you look for what's called an implied domain. A regular domain is all real numbers. An implied domain is if you have one of those 3 things. Do you have a denominator? Then you have to watch out for it. Do you have a logarithm? You have to watch out for it. Do you have an even radical or even root? You have to watch out for it. Okay? So again, just picture yourself as being the bouncer at a club, and that bouncer is looking for certain people, underage maybe, that they're not going to let in. And so you have to know the rules, and you have to guard that implied domain, that you're going to be careful about what comes into your function if you don't have an interval. All right, so here we go. Otherwise, the process is still the same. So the extreme value process on an unspecified interval, that's what we're talking about. So instead of doing endpoints, you do implied domain. And then you still do critical points. And the critical points are still that the derivative is 0 or the derivative is undefined. Okay, so you really don't have to learn hardly anything new today except remember what an implied domain is. So here you go. Here's your first example. Find the absolute max and min of this problem, and there's no closed interval. Okay, there's no closed interval. So that means we have to check the implied domain. Remember, the regular domain is all real numbers. The implied domain is if the problem has any denominators in it, any even roots in it, or any logs in it. So for this problem, I'm in the clear. I don't have any denominators. I don't have any even roots. I don't have any logarithms. So my domain is all real numbers, which means I have no endpoints at all. And I don't have to worry about endpoints because all real numbers cover, they never end. Okay, there is no endpoint. So then I can go straight to critical points. And the critical points will be the derivative. And my derivative is 3x squared. Okay, minus. Noah, what's the next part of the derivative?
3.
Careful. I've only done the first part. You're jumping ahead a little bit.
6x.
Okay, 6x. Then 3. Okay, so now I take this derivative and I set it equal to 0 over 1 and I set it equal to 1 over 0. So 3x squared minus 6x plus 3 is set equal to 0 over 1, and I put it over 1 so that I've got something to cross multiply. And I'll do the other one as well. And I'll set that over to 1 so I have something to cross multiply. So it's the same kind of process we were working on before. When we cross multiply, we get the simple equation 3x squared minus 6x plus 3 equals 0. But what do you notice about that whole left side of the equation? What do they all have in common? A 3. So let's factor out a 3, and that'll leave me with x squared minus 2x plus 1. That is a problem that can be factored. That factors into x minus 1 and x minus 1, which means x equals 1 is the critical point that I get from that process. All right, when I cross multiply the other way, 1 times 1 is 1. And all of that times 0 will be 0. 1 equals 0 is no additional solution. So I only end up with one critical point, which means I only have one extreme value for this problem. Okay, so then I check my extreme value, f of 1, and I plug 1 back into the original equation. So 1 cubed minus 3 times 1 squared plus 3 times 1 minus 2. That turns out to be negative 1. But if you only have one of them, how's it supposed to be? How do you know if it's a max? And how do you know if it's a min? Right? That's a little bit of a problem because we're used to having at least two things we can compare to each other. And this time we only have one. All right, so now we got to put our thinking caps on and use some of our common sense. Let's look back at this original question. Okay? What is the name of that type of equation? What kind of equation is it? Like if a squared makes a parabola, what's this one? It's not a trick question. What's it called?
Curve.
Say that again.
Curve.
It is curved, but it has a special name.
Parabola.
Parabola is with a square. This one doesn't have a square. It has that power on it right there. Ooh, no, it is not a hyperbola. Okay, what is the name of that power? What's the name of it? That's the number of it. What's the name of it?
Try.
No?
No, it does not start with a try.
Okay, cube. Okay, this is a cubic equation. All right, what do cubic equations look like? kind of. I call them a snake equation. Okay, they kind of look like this. All right, so cubic equations, some cubic equations, Jeffrey, do that, like that, what you're doing. Okay, but if it's like that, doesn't it have a max and a min?
Yeah.
Mine doesn't. Mine only has one.
You mean
Okay, so it can't look like that. It can't be a cubic. It has to look like this. It's that kind of cubic. Okay, because that point right there is not a max or it's a min. It's a center point. Okay, so it's different than, there are different kinds of cubics. And if you get both, then you will have a max and you will have a min. But I only got one. And so I don't have a max and a min, I just have like a middle central point there that the curve goes through. Okay, let's go on. Here we go. Find the extreme values of the next one. Once again, I have no interval. Okay, so sad face when that happens. Okay, because intervals are nice, because we know we can just check the beginning and check the end and be done, but this one doesn't have an interval, which means I have to do implied domain. And when I have an implied domain, I have to check for those same three things. Does it have a denominator? Does it have an even root? And does it have a logarithm? Well, this one has 2 strikes out of 3. What 2 things does it have? It has a denominator and it has a square root. It has both. Okay, so I've got 2 problems I have to deal with. And remember, denominators can't be 0 and square roots can't be 0 or negative. So I've got both of those problems. So I have to work out that this thing, this root, can't be 0 and it can't be negative. That's how you solve the implied domain. It can't be 0, so I didn't put equal to 0. It can't be negative, so I had to do greater than. Now I have to solve it. Okay, what do I do to both sides to solve it? I square. Yeah, I square both sides. Okay, so I'll put parentheses around it and square, and put parentheses around it and square. So that gets rid of the square root. Okay, now what do I do? Subtract 9. Now what do I do?
Dividing by, no, it's.
Can't take the square root yet. I can't.
Take out 0.
I have to divide by -1. What happens specially in math when you divide by
Change sign.
-1? Okay, the sign switches around. Now what do I do? Okay, and when I take the square root, what do I get? Oh, good job, plus or minus 3. Okay, I have 2 critical points, plus and minus 3. I have both. And so that gives me 2 things I have to check. I have to check f of regular 3, and I have to check f of -3. So I have 2 to plug back in and check and see what their values are. That is the implied domain. It takes the place of doing endpoints. Okay, so this is the way you find them without doing, since you don't have endpoints to work with. So you just plug those back in and you get the numbers. You still check your critical points. All right, so then I'll move on and I'll check my critical points. My critical points are going to be f prime. But like Kira was working on yesterday, okay, working on f prime with this problem here, you should probably make it a parentheses problem before you work it out. And in fact, I picked the exact same one that Kira picked. And do you recognize it? It's the exact same. Okay. And so do you remember what that turned out to be?
Well, I think the 2 was on the top.
Yeah, so we end up with, oh yeah, we had an extra 2 on the top, I think. Okay. So we end up with a derivative, since we already worked that out earlier. Okay. We end up with -x over 9 minus x squared to the 3/2. Okay, so we already worked that out. What do we do with that derivative? We set it equal to 0 and undefined, and we cross multiply and we work it out. So it's the same rhythm over and over and over again. So I'll do the math on that. I'm going to do that on the side over here. I'm going to take -x. I'm going to move it up a little higher. Okay, I'm going to take -x over 9 minus x squared to the 3/2. And I'm going to set that equal to 0 over 1. And I'm also going to take it and I'm going to set it equal to 1 over 0. And I'll crisscross cross multiply. And when I do that, I get another critical point of x equals 0. And when I crisscross cross multiply the other way, I get plus or minus 3, which were the same critical ones I got before. So nothing new. The only new one I have is x equals 0. So after all that work, I now have 3 things to check. I have f of 3, I have f of -3, and I have f of 0. So I'll check all of those, and you can use your calculator to do it because you're working with square roots. Okay, but you can plug your value in and check those and then compare what do I have from what's my max and what's my absolute min. Okay, are you clear about how to finish that if we just don't get our calculators out and do it right now? Okay, so I just have one more example, then we can get to it and be done faster. Okay, so this is the last one. Again, no interval given. So implied domain one more time. Okay, there is no closed interval. All right, so implied domain. Once again, we have a square root. That square root has to stay positive. Don't worry about the x. There's a little x sitting out in front. That's fine. There's no rules about that x. There's only a rule about the square root. So we only need to work on the square root when we're solving our implied domain. And so we'll do the same thing. We'll square both sides. That will give me 16 minus x squared greater than or equal to 0. I'll minus 16. It's looking really similar. I'll divide by -1. That'll give me positive x squared, switch the sign around. And then I will use my plus or minus, and I get plus or minus 4. So from the implied domain, I get two numbers to check. I will be needing to check f of 4, and I will be needing to check f of -4. Then we move on to our critical points. And for our critical points, we're going to need to work on the derivative. Now, this one we'll have to figure out ourselves. Again, I'm going to suggest that you write this problem with parentheses before you tackle a derivative. So let's look at that a minute. It would be f of x equals x parentheses 16 minus x squared to the positive half. What is understood to be between the x on the outside and the parentheses on the inside? What's between those two things? Multiplication sign. So if there is a multiplication sign in between them, what rule do we need to find our derivative? We have to use the product rule this time. Okay, so not only did we need the parentheses, but we need the product rule. So remember, our good old product rule from first semester, it has 4 parts to it. 1, 2, 3, 4. Okay, 4 total parts. So we'll start with the 16 minus x squared to the half. That's the beginning. And then times the derivative of x, which is just 1. And then x, and then times the other derivative. And this is similar where you got to move the 1/2 to the front and have 16 minus x squared, and its power is -1/2, and then chain rule for -2x. Okay. All right. Oops. Okay. So then we have to clean this up and say, okay, what's in the numerator? What's in the denominator? What do I need here? So this first part can just clean up as 16 minus x squared. But the second part is going to need a numerator, and it's going to need a denominator. So I just got to look at, well, what's left in the numerator and what's left in the denominator. One thing I can do is that because I had the chain rule at the end that has a 2 in it, I can reduce with the 1/2 that was in front. So that helps clean up a little bit. All right, what do you notice? What's left in the numerator now? Yeah, there's more than just x. There is x for sure, because that's right here, but there's more that's going to be in the numerator. Okay, and there's even more than that. That covers this x right here, but isn't there any more that has to be in the numerator? What's left? A negative. Okay, this negative here also has to be in the numerator. So we have negative x squared in our numerator, and our denominator will have the square root of 16 minus x squared moved to the denominator. So now I need to get a common denominator between these two so I can put them together. And so Jeffrey was working on that on an earlier problem. The way for us to get a common denominator is to multiply this one by 16 minus x squared so that the denominators match, and then multiply the top by 16 minus x squared. So I'm going to have two of those square roots multiplied by each other. So this is rad 16 minus x squared times the second rad 16 minus x squared, which is going to just make regular 16 minus x squared. So my first part is going to be plain 16 minus x squared with no square root on it anymore, with 16 minus x squared as its denominator, and then plus negative x squared, and 16 minus x squared as its denominator. So we got to put all that together. I have two denominators that are the same, and so I can combine the numerators. So I'm going to go down to my next blank slide. I think you have one more blank slide on there for you to write on. So the numerator, or the denominator, will be 16 minus x squared. The numerator is going to be 16 minus how much? 2x squared. Okay. So that was a lot of algebra to do before we can set it up equal to 0 over 1 to cross multiply and 1 over 0 to cross multiply. So that's the next step. Set this equal to 0 over 1 and do the cross multiplying. So the cross multiply one way is going to give me 16 minus 2x squared. The cross multiply the other way gives me equals 0, and then I can solve that. So I'll minus 16 to both sides. I'll divide by negative 2, and then I'll square root, which gives me plus or minus rad 8. So now I have two more numbers to use with the numbers I got in the implied domain at the beginning to add to that listing. So let me slide back up. I already had f of 4 and f of negative 4. Now I have f of rad 8, and I have to add to that f of negative rad 8. I didn't leave myself enough room. So I've got all of those yet to compare. And the last thing for me to do is to cross multiply with 1 over 0. So last step, I can almost taste it. We're done. 16 minus 2x squared over rad 16 minus x squared. Now I'll be equaling it to 1 over 0. And we'll cross multiply that. Then we'll get 16 minus x squared equals 0. And when we finish that one, we're going to get plus or minus 4, same as we did before, so that's nothing new. Okay, no new numbers. So I really only have those original 4 to check. I'll use my calculator to check f of 4. I'll use my calculator to check f of negative 4. I'll use my calculator to check rad 8. And I'll use my calculator to check negative rad 8. Okay, so I'm just going to assign them out so if you can we can get these done quickly and we'll just kind of work it out. Jeffrey, you don't have your calculator. Noah, do you? Okay, can you do f of 4, please? Okay, Leo, do you have your calculator? Okay, Sue, you do. Can you do f of negative 4 for me? Okay, Nick, can you do f of rad 8? And remember, you're plugging it back into the original. Christine, you have your calculator out. Can you do negative rad 8? Okay, so if each of you could do 1, that would help us out. And then we'll be done. And I have identified the max of the maxes and the min of the min. Okay, so Noah, are you ready?
Yeah, that's 0.
You got 0. Okay, so he did f of 4. He got 0. Leo, are you ready? Or no, Sue, are you ready?
Yeah.
What'd you get?
0.
You also got 0. Okay, so far it's a tie. Okay, Nick? Almost. Okay, Christine, let me know when you're ready.
I got 8.
You got straight out 8?
Yeah.
Okay. was trying so hard to get it done.
I'm stuck.
Okay, it should be -8. All right, so then you can identify that the maximum is 8 and the minimum is -8. All right, good job today. I'll see you Thursday. I won't see you tomorrow anymore, so I'll see you Thursday afternoon.